Good afternoon, everyone, and thank you for joining us today for the first session of Aquatech Week 2025. I'm Alex Retsky, Digital Media Project Specialist for Aquaculture North America, and I'll be your moderator for this session. Now, without further ado, I'd like to pass it over to the team from SEAPA for their presentation.
Thank you, Alex. We're very excited to be with you here today. I'm personally dialing in from Australia, so it's very early on Wednesday morning. Just to give you a brief introduction on who we are as a brand, we very much focus on one principle that there's no one-size-fits-all solution. Our systems are engineered to adapt, whether it's for hurricane resilience in the East Coast of the US or trestles in France. We believe that our global experience, our in-house manufacturing, and the boots on the ground teams helps us to co-create gear setups that each grower's environment will suit best. So in this session today, we'd like to showcase some of the global methods that we've used, but really focus on what works best for the US, region by region. So just to take you through a little bit about where we started back in 1998 in South Australia, and we started by partnering with a local oyster farmer. We built the brand on the need to solve real farming challenges with purpose-built gear. As I mentioned, we're headquartered in Australia, and the focus here in Australia is really on the design, the testing, and the manufacturing that we can then roll out across our global presence. We're lucky enough to have regional offices in Japan, France, and the United States, which allows us to keep stock locally, support with on-the-ground teams, and have those technical insights available that specific nuances to each region really requires. We believe very much that you need to work alongside farmers. We don't just sit in the factory or in the boardroom. We're on the ground, we're on the farms, and we need to understand how everything works on a specific farm. Leading into that, our approach has always been field-proven, engineering-led product development that we grow with our customers, and it's spanned across decades and coastlines. Lastly, just talking about our gear, we've got a variety of solutions for different growing cultures and for different environments. We believe with the right gear, the right outcome will be achieved based on what your conditions are. So before we go into a little bit of the details, I'd like to just give a quick snapshot of some of the major learnings we've learned from the lessons we've learned from our other regions before we go into detail with the US in particular, and just to show how we've been able to apply those local nuances to really understand how gear needs to be fit for purpose. So our gear doesn't just survive the tough conditions, it helps oysters thrive. And as I mentioned, this is how we enable with our teams and our offices across the key oyster growing regions around the world. We're really on the ground, testing the gear, understanding what the local nuances are, and giving real world feedback to what needs to be adjusted. Some of the markets that I'd like to share with you briefly, just touching base on Australia, where we originated, where we start off our ground roots, our grassroots. In Australia, the market is very much in a flux with high labor costs, low employment, aging workforce, and a little bit of a disinterest from the younger generation, as this is especially the case in the late 90s when we started. And a lot of the farms were located in a little bit more of a rural area, which made these factors obviously a little bit more difficult as well. There was a need to increase the shelf life of oysters so that they could reach the market well. And that's where the invention of the basket, of our specific basket with the focus on rumbling and tumbling, came in, that allowed that oyster to be rumbled, to deepen the shell and really smooth off any frill, focusing on the growth of the abductor muscle and then extending the shelf life in turn. Currently in Australia, we're seeing a lot of consolidation happening with the farms, which we're hoping will lead into better funded businesses, which always tends to drive innovation and unlock new opportunities in market. We're working on a couple of deep water availabilities or deep water solutions, as there's quite a lot of deep water left available in terms of leases. So it's quite interesting to see how that will work going forward in the market. If I touch base on France, what we learned from France and how we were able to take the Australian basket and apply it to a French nuance. We've got good partners all across France, but obviously Normandy being quite well known for some of the most severe storms and weather and extreme tidal ranges. So historically, France is very traditional, focusing on pushes and trestles. The trestles are used for stability for these tides and storms. But it's quite a labor intensive job, specifically when the pushes needs to be flipped and that it can only be done when the tide is low. This will then have to be for harvesting, for maintenance, for everything that needs to be done. France also had quite a lot of water quality concerns, not only with the storms and fresh water from the rains and rivers, but also they had a very severe impact of the norovirus recently, or a couple of years ago. Which really resulted in oysters growing in other markets and finishing off in France, which often has heavy investment, reliance on hatcheries and depuration of the water. So what we did with our partners is we took the Australian basket and we adjusted the application process. So we needed to make it fit on existing French infrastructure. So we enabled it to be adjusted onto the trestles by adjusting a clamp bearing or installing a clamp bearing and allowing our special stormbreaker clips to be housed on the clamp bearing and then placed onto the existing infrastructure. This not only drove a little bit of innovation for this market, but it also helped with flexibility for existing farms. And currently we're seeing quite an interest in moving to adjustable long line in France, which will be interesting to keep an eye on that development. And then lastly, in Japan also used to be a very traditional farming, used to follow traditional farming methods. They have similar challenges such as the aging population. They have a very high demand for premium oysters, driven by oyster bars and the culture there, but rising costs that make it very difficult to have a viable business model, specifically for commoditized oysters. The transition had to be made to really focus on growing a premium oyster, and the only way to meet that demand was to turn to deep water. So subtidal was offered a lot of solutions as the intertidal or the more shallow areas were already leased up. And there was also a drive from housing and tourism not to expand any additional leases in close to the shore. But what does prove a little bit more difficult is the ability to rumble that oyster in the deeper water. So what we were able to do on some of our farms with our farm partners was adjust our basket with specifically, again, the stormbreaker clip onto a floating long line. This was a very cost-effective way to install based on the limited space that you needed, and it enabled them to just expand their businesses quite efficiently. You obviously still then need to manage fouling, but the baskets allow for rumbling in the deep water. And interesting enough, currently we're seeing a lot of semi-automated surface systems that allows that reduction of maintenance and fouling and extending in deeper into the water column. So just a little bit of a snapshot to show where we have been able to take specific gear that we developed in Australia, but adjust it to the local nuances, which is really the key important area. And at this point, I'm going to hand over to the experts to tell you about how we've done this in the US as well.
Thanks, Monique. I want to take a quick minute to introduce myself. My name is Eric Schlagenhoff. And before I worked with SEAPA, I spent about 14 years directing oyster farm operations on the West Coast. I was using 4 or 5 different types of gear and growing, luckily, 4 species of oysters. But what happened was with all that different gear, managing the gear and the staff that go along with it it ended up being a lot of staff training, a lot of gear maintenance, a ton of labor. We were mainly using Vexar mesh bags, and we had variations of how we built and deployed them. We were using tens of thousands of hog rings and zip ties to build and secure our gear on an annual basis. At one point, I had a crew of 3 to 4 full-time guys performing gear maintenance. We were constantly doing repairs. We were managing the inventory of single-use items, trying to maintain enough workable gear to handle production demands. So I needed to find something, a more efficient system, one that reduced the labor, didn't generate as much waste, and I needed to maintain the quality of the oysters, if not improve it. So I looked at and tried a number of ideas, but after I tried SEAPA gear, I knew I had found what I was looking for. So years later, when I was ready to give my brain and my body a break from farming, transitioning and working with SEAPA was just the natural next step. So we're going to share some stories from oyster farms and areas that they're in across North America. As many of you probably know, or you'll see, conditions along the coastlines can vary quite dramatically. You have different tides and bays, wind exposure, growth rates. Every site presents its own set of challenges. And that's why when it comes to gear, there is no one size fits all. Your gear and how it is set up has to be site specific. I hope this talk sparks some questions, gives you a few ideas about how to improve efficiency or simplify operations at your farm. So I'll start on the West Coast. The West Coast oyster industry is predominantly intertidal, but those intertidal zones can be, there can be a big variety. You can have steep cobble beaches, big expansive tidal flats. Some of those are very firm. Others have super soft substrate and mud. There are protected lagoons, and there's other areas that are just directly exposed to storms coming off the Pacific Ocean. There's also a smattering of subtidal and floating culture systems found throughout the West Coast. So because of this diversity of environment, farmers have to use a wide range of methods for production, and most are trying to achieve a kind of a highly tumbled, consistent oyster for the half shell market. The tidal range can vary quite a bit, from about 4 feet down in San Diego to 16 or 17 feet up in Washington. And because of the large tide ranges, instead of using an adjustable longline setup, the kind of the traditional method from Australia, many growers use just a single line height on their intertidal longlines rather than trying to adjust the gear up and down. Hanging Vexar bags from long lines with floats are pretty common to achieve that highly tumbled and polished oyster. SEAPA baskets work really well in the same scenario. In these single line setups, especially when lines are set up perpendicular to the wind and wave action, that helps to capture the energy and helps shape the shell and improve the strength and thickness. Some growers are even taking advantage of our basket's narrow profile. They can stack 2 lines on top of each other vertically, dramatically increasing the number of oysters that they can plant per acre. I will say, though, that anchoring in that situation becomes even more critical for those lines. In a typical layout for intertidal lines, they're spaced about 2.5 to 3 feet apart. We generally recommend 4 lines in a row, and then a space for a boat access. This allows a farmer to walk down the middle of 4 lines and easily shuttle baskets to and from the boat and maintain easy access. Keeping the line heights and stocking densities consistent is very important. It saves a tremendous amount of time during the processing and sorting by keeping the growth rates and shell quality more consistent. Farmers also are using baskets on floating long lines, often as a way to expand their nurseries. So I want to take a moment and expand on one farm in particular. The photos here are of long lines being built by Hog Island Oyster Company in Humboldt Bay, and they have adapted their SEAPA gear for their operations there. So Hog Island had already been using SEAPA for a number of years in Tomales Bay. One of the challenges they faced there in Humboldt was soft substrate, causing anchor posts to pull in and their lines to get slack. So standard anchor posts just weren't going to cut it. They resolved this by switching to a knee brace design from the anchor post to the first riser post. It was just a small little change that they came up with, but it was really easy to do with our system, and it kept the long lines really stable and taut. In Humboldt and up and down the West Coast, there are really strict regulations regarding eelgrass and the farmer interactions with that. The gear needed to be configured to avoid damaging any of the SAVs. Hog Island needed to develop setups that kept baskets off the bottom, away from eelgrass. They needed to maintain the good growth conditions and not lose their efficiencies. Intertidal long lines just fit this box perfectly. So another one of the challenges for Hog Island is securing their gear. They really don't want to lose any of their gear. That's where SEAPA Stormbreaker clip system has come into play. It's a clip and bearing system that takes the wear off the line, allowing the clip to rotate around a bearing. It really provides a high level of confidence, and it works really well for any farmers that are using Stormbreaker clips, baskets with floats on it. So really great that way. This really reduced the amount of time repairing gear or going after gear that was lost. And I think these examples just show the importance of adapting to the local environmental factors. You know, with the right system in place, Hog Island has been able to nearly double their productivity and maintaining efficiencies, being able to adapt to regulatory and environmental conditions. So I'm going to move down the West Coast, down to Baja, California. Farmers faced a logistical problem. They were growing oysters in Guerrero Negro, but they needed to process them near Ensenada, which was, I think, about 400 miles away. They had really limited access to reliable cold chain infrastructure, and the quality of the oysters often suffered during transport. What we did is similar to Coffin Bay in Australia. The farmers in Baja had similar tides that were smaller, and we could use the same methods developed in Australia as the backbone for the system. And the trick was to put in the traditional adjustable longline system, both for the grow out and just to increase the transport resilience of the oysters, to really toughen them up. This is also a location that can be a little bit trickier to get gear to. So any equipment that they get there, it has to last. And I'll say that I've talked to farmers, and there are still SEAPA baskets out there working after 20 years of use. So I'll talk a little bit more about the adjustable longline system. They use the system to promote tumbling, to strengthen the shell structure and extend the shell life. By being able to raise and lower the lines, you're able to control the growth up and down in the tidal range. When you move them down, you can promote growth, faster growth, and when you move the lines up, you can slow the growth down and really toughen up the shell. And a crew of two could move hundreds of baskets on just a few lines in less than 20 minutes. So really an efficient way to manipulate the growth structure of your oysters. And instead of transferring the oysters to different containers, they were able to keep them in their baskets, which minimized the handling that was needed and any potential damage as they transferred them up to Ensenada. Those same baskets were reused in a subtidal stack. So now they were able to take those baskets from the adjustable longline system, and now they're able to submerge them subtidally, almost like a ladder system. And this acted like a live wet storage, keeping the oysters fresh and ready for processing. It's a flexible gear system. It supports farming, transporting, and finishing. It's a great example of cross-regional insights. Taking insights from Australia and applying them into Mexico. Next, we're going to hear a little bit about the Gulf Coast.
Thanks, Eric. G'day, everybody. My name's Ewan McCash. I'm SEAPA's East Coast sales representative. I'm an Australian, but I'm based here in Portland, Maine. My background is I'm an oyster farmer of 20 years. I still own and manage a family farm back in Australia. Our farm grows 2 species of oysters, and we farm using the SEAPA intertidal system. In fact, I'm one of those farmers that Eric mentioned. I'm still using the same SEAPA baskets I purchased 20 years ago. So it's been a very robust and productive gear choice for our family farm. Kicking off in the Gulf Coast is one of the most exciting oyster farming regions in North America. Historically, it's accounted for like 80 to 90% of US oyster harvest, and the industry is now shifting from bottom harvesting to farming off bottom and producing premium restaurant-grade oysters. The Gulf has warm, nutrient-rich waters. It's an environment that fuels rapid oyster growth. They can bring oysters to harvest in as fast as 7 months. However, that same productivity also presents a significant challenge in the form of intense biofouling. Where the tidal range allows, the adjustable longline systems can be used to mitigate biofouling, as the oysters periodically dry out every day. This system also, as Eric mentioned, harnesses wind and wave energy to tummel the oysters, so resulting in a cup shell growth with reduced labour, not having to tummel those oysters physically. The major challenge in this region is, of course, hurricanes. So any cultivation gear needs to be robust, it needs to be well installed. Adjustable longline systems hold up well in these conditions. And although not all states permit this infrastructure, in this picture you can actually see a longline system from Murder Point, Alabama. They're a well-established farm, and this gear has been through many hurricanes over the years. On to the next slide. So floating systems are the most common cultivation method on the Gulf Coast, as it enables farmers to cultivate a broader range of areas, not restricted by depth or the tidal movements. The intense biofouling is managed through a weekly process of flipping and drying oyster baskets. The fast growth also means that creating labour-efficient oyster handling is a key priority for these farmers. And for this environment, SEAPA's actually developed the Revo floating system. Revo features a surface drying design that allows farmers to easily flip and dry the baskets by hand or using mechanised equipment that we supply. The design ensures baskets are sitting high out of the water to maximise that air drying time. And a key differentiator of the Revo to other flip systems is the versatility to remove the baskets from the line for filling and harvesting, and also remove the floats for hurricane prep. Scalability is key here. We've got a lot of new farmers entering the industry. This system allows them to start small, automate early, and provides that flexibility to process either on the water or on land. And again, that's key because depending on how much access you have to, working waterfront, or if you're working from a boat, having a system that's really versatile enables you to sort of become productive a lot faster. So for an industry transitioning from large, wild harvested oysters, where the product was originally sold as bulk meat, Revo is designed for farmers to step directly into premium, brand quality oysters for the raw market with better shape and control over that sizing. We've currently got Revo deployed across Texas, Alabama, and most recently from Little Movement Oysters, located here in Grand Isle. You can see Ryan there. Ryan's a good example. He's a fairly small-scale farmer. He's spent a few years understanding how to farm his site, and the Revo floating system is on point for his sort of production method. So the East Coast has the full range of oyster farming conditions. Gear choice is driven not only by the environment, but also by regulation in the different states. In Florida and Georgia, much like the Gulf Coast, the low tidal range leads to the use of floating systems. and the need to efficiently manage biofouling is important. In South Carolina and North Carolina, they've often adopted adjustable longline systems to mitigate both the biofouling, but also manage summer mortalities. So the ability to actually raise their oysters up out of some of that hot water, so they're less exposed over the summer period to bacteria and other sort of will have a bit of a rest and recover out of the water as being key in sort of reducing some mortalities in that area. And like all southern states, the farmers in these areas have got to manage for hurricanes. They need well installed, robust gear that can ride out a storm. Grow out times in these waters range from sort of 7 to 18 months. Chesapeake Bay in Virginia and Maryland is historically the East Coast's largest oyster producing areas. They've also got some of the largest farms on the East Coast, and they're typically employing floating systems as the industry transitions from that sort of harvesting off the sea floor to off-bottom culture at scale. Moving further north to Cape Cod, Massachusetts, water temperatures are getting colder. They have very high tidal ranges of 8 to 10 foot. And in this region, we shift back to intertidal systems, typically long lines or steel trestles to suspend baskets off the bottom. However, to avoid winter ice flows, these systems need to be removed and reinstalled each season. Floating culture is not permitted, and height restrictions influence farming systems. Very similar area to France, although maybe not with as higher tidal movements. Further north into New England, Maine farmers might take 3 and even 4 years to bring their oysters to market. Again, a real focus on efficiently managing oysters over that long period of time. Their oyster leases tend to be much deeper water, and they rely on sinkable floating system to overwinter both the gear and the crops below ice flows. In this region, we've got the SEAPA Revo currently being trialled, and we'll be removing the floats to winterize those oyster lines. So the regional differences really underscore the importance of having a system that can adapt to each environment, ensuring that farmers can be compliant with both the state regulations and maximize productivity at that site. Moving on to the seed stocks.
Sorry, Ewan, I'm going to interrupt you there. We unfortunately enjoy talking so much that we're almost running out of time. Very aware that if we get the floor, we would sit here and talk the rest of the day because we're so passionate about the industry. I'm just going to hand over to the experts and obviously to Alex. Let's open up for some questions if we still do have time. Just sharing our contact details there. If you are interested in visiting one of our existing farms, joining a list for any trials, give us a scan, reach out to us. We'd love to speak to you and just to understand what your current conditions and challenges are and see how we can hopefully work on those together.
Awesome. Thank you guys so much. We got a couple questions here, so let's just jump right in. The first one that I see here is, could you please expand the concept of single seed farming done in Japan as mentioned in one slide?
Yeah, so traditionally, oyster farming in Japan had been clusters hanging on wires from rafts. That way of growing oysters really wasn't working for them. And particularly after some of the earthquakes and tsunamis that they suffered through, they had to rebuild their industry. And there were some pioneers in Japan who said, well, if we're going to rebuild the industry, let's rebuild it in a way that's efficient and can get us a higher value product. And so they really started to use SEAPA first, floating long lines. There's a little bit of intertidal in Japan, not much. And now they're transitioning over to our Revo system, which is it's a surface drawing system.
Awesome. Thank you. Looks like we got time for one more question here. This one's asking, can you walk us through how SEAPA collaborates with new farmers during early setup?
I'll take this one as well. So really what we do is we work with the farmer. We really try to understand what their site, where their site is, what the conditions are at their site, what their challenges are as the farmer, and really address those challenges to figure out which SEAPA system is best for them and how to install it, there's so much variation. So we really try to walk them through almost every step of the installation process and start with small trials, making sure that we've got it dialed in before they expand in a big way.
Well, unfortunately, that is all the time we have for the first session. I just wanted to extend another big thank you to the team from SEAPA for that awesome presentation. Really appreciate it, guys.